Hi there, welcome to Cloud Native Skunkworks. This video is Ohmyyaml. The video is about Terragrunt, Terraform, Helm, Docker, Golang, and Kubernetes deployments to show how you can build infrastructure and deploy applications on top of it from a single repository. I've included a sample repository that is in the description called Ohmyyaml, and that is what I'll be investigating and looking at today. My ambition is that you can come away from this video understanding how Terraform and Terragrunt interconnect and how you can see it's a far more sustainable way of building out dry configuration. In a prior video of mine, I looked in detail at how the structure of Terragrunt works. This video is going to articulate and hone in on how can we build an application all the way from writing the code up to delivery on the platform. So I'm going to talk us through in a screen share. We're going to look at the various components, and hopefully at the end of this, you will understand how to do it for yourself, but also start to think about what are the benefits in doing such a methodology versus what does your current platform landscape look like. And again, making a mono repo for infrastructure might not be something that you always think is the best situation, the best way of doing something, but it's a really good way to understand the tooling and how it interconnects. And also, I think it's quite a nice, concise little example. I would always look to differentiate Helm, Terraform, and Terragrunt in a production environment because you potentially have a chart museum, you'd have a Terrafom module catalog repository, and then you'd have a Terragrunt repository holding your configurations. But again, what we're going to look at today is how do we put this into practice and what are the learnings from this? Because there's a hell of a lot of stuff that we'll end up learning. So without further ado, let's have a look. So I have on the left here my Ohmyyaml repository, which I'll make available in the video description. Ohmyyaml essentially has three primary folders. We have our regional configurations. This regional configuration folder is a fancy way of saying our config for Terragrunt. This folder, called module catalog, is where a lot of the plumbing goes, and this is our Terraform module. Our Terrafom module catalog, whichever way you want to slice it. It's the part of our repository that holds all of the information about the stuff we care about in Terraform. Let me find a cool background we can use. That'll do. And the final piece of this, which we'll start with, is the application, so the app repo. The app repo gives you an example Golang server that will display a picture, and it will display, I think, a gopher. So what I want to do is show how you can combine all these three things in a single repository to effectively build and maintain a scalable Kubernetes-based deployment on a cluster that we will be running in the cloud. So let's just write this down so it looks accurate. Now I've called this Kubernetes substrate, but for this video I'm using EKS. I'm using EKS because it's one of the more advanced and mature Kubernetes platforms, but also it's probably far more likely you'll be working with something like EKS or GKE in your own company or organization. So let's take a look at what I'm talking about. On the left of my screen here, and I'll just blow up this to make it a little bit easier to read, is the app. If you take all of this aside, the app constitutes a main.go, an image, and Dockerfile. So let's go ahead and just run that main.go. So in a new terminal here, I'm going to jump into my repository, and that's app, and you can run this yourself. The only difference between what I'm running and what you'll be running is that I have my dependencies already downloaded, so I don't have to go through the fetching process. So what you'll see is that on localhost 8080, we are serving up a really simple picture. And this is the typical kind of interview question of, hey, serve me a picture. And the way we've done that is super simple. I'm doing an open on that picture. I'm then doing an IO copy, and then I'm writing it into the response writer for our HTTP handler. For more on that, you might want to look at, I believe it's net/HTTP docs that'll tell you how to get started in Golang. So this is effectively our step 0. So from step 0, we've written a new application. Step 1 would be Dockerize application. The Dockerfile here, as you can see, uses a simple builder pattern, and I could take that further by making it a multi-part build, but I haven't done so because I've not yet found a necessity. And what I mean by that is we can add a second file that we pull in, like Golang Alpine or an Alpine runner, and we copy the binary into that, and we can do a copy and we can pull the binary in. But just for the simplicity of this video, I've tried to keep it really nice and concise. So we're copying the current working directory into the Docker container. We're then doing a build, and then we're exposing it and running on the entry point. This could be better. You might not necessarily want to copy everything from your current working directory, so there are plenty of tweaks that I'm sure that you can make and contribute back to the repository. So far so good. We understand that we can build it. We understand that we can run it in a Docker container. What else? This is where I like to start to use makefiles. Anything that involves more than a few different commands, I like to use a makefile. And this is just a personal preference over using a shell script. A shell script, you have to tune the arguments, right? So you have to start passing the arguments at position 1, position 2. These positional arguments can be kind of hard work to work with. Whereas a makefile, you can call the target directly. And I'm not saying one is better than the other. Just for me, personal preference is that if we go back to this makefile, I start building this out as we're going. So I have a simple makefile now. I can do a make docker. You can see now that on my M1, I've not got the Docker socket running. So let me just start that up. And we do a make docker. And hopefully, once Docker started, this will go off and do my Docker build. This Docker build is super simple. And what I'm doing is pushing the artifact to Docker Hub on my private repository. And you can see here it's building, and there we go. I got a couple other commands built in here. So we've got Docker push, Docker run, and these are great for testing, right? I want to make sure that that thing that I just tested in localhost also works on localhost when I have Docker running. So let's go back and just check what's going on. Let's do a make Docker run. Starting the HTTP server, and if I refresh, great. I can see that these are incoming requests to the Docker container. And we'll talk about overlay networks and the way that Docker networking works another time. But for the sake of this video, we can see that we have an incoming request. So great, we understand that we have a simple app, but what about deploying that app in the context of a single infrastructure and configuration repository? It's a real mouthful of words there. Okay, so look, what's next? Before I can really get anywhere, I do need a deployment substrate, and I need the configuration language to describe how to deploy my app. So what I've done is create a Helm chart. This is doing a simple Helm create chart, and then I've called it Ohmyyaml. It has pretty much default settings other than the image being set up, and I've cut out a few pieces of the templates. An HPA, so horizontal pod autoscaler, isn't necessary for what I'm doing. Equally, I only need the simplest form of ingress and service account. So the only real thing I've done with the ingress is to make sure that the class name is set to true, set to Nginx and enabled as true. What I also will need to do, and what you might need to do, is to update the hosts. Because when we start using Cert Manager, when we're trying to then provision this chart, that is not going to work because we will not. This will be on the local on the Kubernetes cluster. It won't be matching a domain name which you control, and you cannot then validate through the Acme challenge over HTTP by routing that the certificate can be provisioned. So I will change this just as an example to. In fact, let's change this to Cloud Native skunkworks.io, which is a domain that I own. So we'll then change that. And another thing we need to do is change it from chart example to Ohmyyaml. There we go. And this is effectively all you'll need to do is to change that. The idea, as I'll come to it, is that Cert Manager will take care of a lot of this. And again, this video isn't really to describe what these technologies and tools do in great detail, more how you can consistently pull this together in a single repository. So we have our application, we have our chart for application, and you'll notice it's locally hosted at this point in time. And that is an interesting challenge. We don't have it hosted on a Helm chart. We haven't got it in a tar.gz somewhere yet. So the next thing we want to do is start thinking about, okay, well, maybe we want to get Terrafom involved. At this point in time, I want to start thinking about building a Terraform catalog of modules. I call it a catalog because I think about one of those shopping catalogs where you could look through and pick out toys and you could circle the thing you wanted. So it's the same kind of methodology. The catalog itself is broken into folders that represent these modules. They're a module in that they are compliant to TF linting standards. They have a main TF, an outputs TF, and a variables.tf. In fact, this one here for deployments does need an outputs.tf, even if it's empty, otherwise the linter will fail. So in the main TF, typically best practice, in my opinion, is to put the Terraform required providers. And then in the outputs, it can be populated if you want, and then the variables. You'll notice something important is missing here. We have no providers defined. The AWS provider is mentioned as a requirement, but it's not defined. And that is where we'll talk about Terragrunt and give a bit of a very refresher on that in a moment. What I'm doing is provisioning an EKS cluster inside of this module. So it is a local module called infrastructure substrate, calling a remote module EKS AWS. This is a very simple configuration. You'll see that it has the bare bones, and you can use this and get up and running. You may find that you have to modify your CIDR range because this is dependent on your region and then your VPC. So I'm using the default VPC for my region, and so therefore I have a well-known set of divisible subnets. And so I've gone for the end of the range of subnets on /24s, and I think I started with a /16. And this then means that I can really ensure that nobody else is using them in my example, put them right at the end. And I'm using these for my two different availability zones because the EKS cluster by default will want to put nodes in each zone for resiliency. So that Kubernetes substrate, as we've described, is going to be running on EKS. That EKS cluster, if you've worked with AWS before, has a two-step process of provisioning the control plane, and then it has the worker nodes. In my example here, I believe I've attached 3 micro nodes, so a really small cluster, just for the sake of this demonstration. So there we have our worker nodes. What else I've done in this EKS repo is I have set a few Terraform specific parameters, depends on. The depends on command is useful because we're going to ensure that AWS is provisioning the subnets prior to EKS. This is actually one of the less stable modules I've found in terms of the idempotency of it. It often requires resources to be run several times before it will completely create them. And I believe this is a fact of the AWS API not always being completely congruent with its responses about the status of resources. Some of them are fire and forget, for example. So let's take it a step further. We've got a cluster being deployed in this infrastructure substrate. Well, that's all well and good, but how do we actually call that without a provider? That's where the regional configurations come in. And if you watched my Terragrunt video, you will see the similarities here. EU West 1 is what I'm calling it. And inside of the environment-specific config, I've set a local called EU West 1. Inside of EU West 1, we're mirroring the module catalog for that region. And you can see we have a Terragrunt HCL. Let's do a quick refresher on how Terragrunt works. The power of Terragrunt is the ability to read parameters from files and its injection command through generate. If you look at this file, effectively, if I was to summarize it, it's fetching a Terraform repository, it's injecting a provider with some variables, and it's setting some inputs in the variables as well. It looks complicated and it might look a bit foreign if you've not worked with this format of HCL before, but once you get into it, you realize actually there is a lot of methodology behind the madness. So let's just have a think. What actually is happening here is we've promised to generate this provider for AWS. Remember I was saying that was missing a moment ago. We've also set a region in that provider. Now that region is being pulled from the file above, because if you see here, I've said, basically, go look for this file. Wherever it might be, go look for it. It's above you somewhere. Once you've found it, I want you to hone in on the locals, I think it's a map, and look for the environment variable. that environment variable, set that locally here, and then use that environment variable locally here. So there's a chain of custody so that all modules inside of EUS1 deployments will be specifically tuned to EUS1. And this is the beauty of how Terragrunt allows you to keep your infrastructure dry. I cannot emphasize enough how much better a methodology this is than this spew of repeated Terraform resources all over the shop that all need manual intervention, that create these enormous state files, because often folks will want to keep them in one giant state file rather than having to manage multiple. In fact, the secondary benefit here is that we are injecting the workspace as well. So from the root level Terragrunt HCL, the Terraform backend gets injected into the current running module. I covered this in my previous video, but just to reiterate what I'm saying, if I'm currently running the module of, let's say, infrastructure substrate, it will generate a provider file and it will generate a backend file. And we can prove this because in the cache, where it actually checks out this stuff locally, you can see, lo and behold, we've got our provider file. Lo and behold, we will also get all of the other pieces that needed to be injected in. So the state has been set. We have a state as well. So this is brilliant. So Terragrunt is how we're going to run this. But already, again, we're starting to involve some complexity. I like to keep things simple. That's why I write these up as Makefile commands. Terragrunt plan infra. Let's run that. Make Terragrunt plan infra. Now, I think in this video, I have a couple of variables that I haven't assigned. So I'm just going to check. Let's see what happens. But you see what happens is it changes directory into the infrastructure substrate. I do this is a force of habit. I trap the exit command because if this fails, I do not want to be stuck in that directory. So trap is a really useful command that enables you to register on particular signal types and to run a command afterwards. So if the next command fails, it will trap and jump up 3 directories back to the beginning. And that's just a utility command to keep me happy. So you can see here, by running this Terraform plan infra, it already knows it's going in EUS1. It will figure out what the VPC range is and everything dynamically. However, it understands the VPC address. It understands what we're going to build. Amazing. The next part of the plan is to then run the apply infra, and that'll go on and deploy our substrate. At this point in time, we have a fully functioning EKS cluster. But don't just take my word for it. I'm going to build one. Now, EKS, as a few of you might know, isn't the fastest Kubernetes platform to deploy, so I think the video will probably be finished by the time this has deployed. However, I want to show that it's real, right? This code works. So on top of that, what we should do is look at deployments. So once we've got our infrastructure substrate, we've got all of our networking, all of our roles, everything provisioned through that really nice EKS module, what next? Well, that is where we want to start thinking about how do we get the applications on top. So I have an app that has a Helm chart, but wait a minute, there's something I missed. I didn't say how this all works locally. What you might have picked up is that I'm leveraging Terragrunt source. This is definitively the most important flag to add on Terragrunt. And this is what brings it all together. Without Terragrunt source, you cannot work locally in the same repo. What this allows you to do is to reference a local relative path to run the modules from. That is how Terragrunt knows to run the Terraform module catalog from here, like this, rather than going off to the web. Like we discussed in the previous video, it typically would be looking for a tag, a remote tag. And just to emphasize that point, in the infrastructure substrate, the Terraform source repo is remote. You see, I'm assigning it a tag and it's looking off at something in the cloud. So what we're doing is we're overriding that and we're saying, hey, you can use relative path locally, that's fine. And this is a valid way to work. Typically when I work, this would be for development purposes, and then you would commit these things, you'd cut a tag and deploy. And I would probably think that any mature or larger business would want to have things tagged, so there's a little bit more security than somebody running things locally. However, for us, it's brilliant because we can get started and deploy things. Let's look at the deployments catalog. I have a main TF. This main TF is using the Helm provider, and that Helm provider is leveraging the AWS CLI to get token for the current cluster. Now, what's really nice about this is I'm using the data resource of AWS EKS cluster to figure out, hey, what are the details of this cluster? So what that does is that effectively pulls all of the data out of this cluster, like what the endpoint is, what the certs are, and it then allows me to inject it into the Helm provider. So Helm can connect to that cluster directly. On top of that, we also have our releases. This video contains a few examples that are a little bit more complex than the previous example. The first and foremost change is that you'll notice we have a locals file. This locals file is using a built-in function called template file. For things like Nginx and Cert Manager and Prometheus, the built-in functions for template files are super useful because I can pass parameters into a Helm values file and modify that file before then injecting that into Helm. Now that's a big concept right there, okay? So we take a Helm file, Helm value file, we pass it through a templater function from Terraform, and then Terraform stitches that together as what I will call the rendered Helm file. This seems like a interpolation gone mad scenario, but actually it's so useful because if you're working with, say, a bunch of different ingresses in different environments, you want to be able to interpolate that file and pass in things like the FQDN, and that's exactly what I'm doing. I'm setting an FQDN right here. In fact, let me just remove that, and there we go. The FQDN will get passed in from Terragrunt or the set to default. That then gets called inside of the template file, and then that gets rendered. Now, you might ask, well, why don't you just do a set? Set you can do, but when you're passing through arrays of objects, more complex types of data structures, set really doesn't cut it, and it's quite hard to use when you're trying to do anything beyond a basic Boolean or single line string. So that said, we have a couple of things being deployed. I didn't really mention what they were. So I said we have Nginx. I also said we had Cert Manager. And then I also said we have our Helm release. Now the way that I've done this is I've added in the Makefile a way to deploy the YAML to S3. That's where it's hosted. So the YAML gets pushed into your S3. That is because it was convenient for me. And in honesty, that's because I had some pathing issues. This should work where you can just go up, 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 app, charts, Ohmyyaml. That should work. However, I spent a good half an hour trying to fix this. The path's correct. There is a protocol error coming from the Helm release. So to make this video and to give you a reality check of some of the things that do go wrong, I had to host it in S3. So this was a manual command I ran. And this will deploy the packaged version of this chart. And the way you package it is go helm package dot, and it will create a tar.gz. So this resource is simply going to pull down Ohmyyaml and put it in the default namespace. We're going to deploy Nginx. That Nginx is going to have an ingress resource that maps to the Crystal Basilica domain name to Ohmyyaml. We're also going to get an Acme challenge from Cert Manager, which is then going to issue a certificate for Ohmyyaml.crystalbasilica, which was my previous domain name, which in this video we've called Cloud Native skunkworks.io, and I will alter that as well later on. But now that will effectively issue a TLS certificate, so that is operational through HTTPS, and you can then hit that resource. So to wrap up, what we've looked at was a bit of a whistle-stop tour on how you can make a single repository to house your actual application code, your Terraform modules, and your configuration to run Terraform, which deploys not only your EKS Kubernetes substrate, but also the deployment on top. I mentioned a few times, in fact, I think I made pains to mention a few times at the start of this video, I'm not saying this is the canonical way of working in production. But I think that if you're a new starter or if you're a senior engineer who wants to fiddle around with a few of these things, it's a nice, concise way to have a single repository where you can deploy stuff out. The trick in making this work is using the Terragrunt source path. And there are some caveats. As you saw, I had a relative path on the Helm directory. Ordinarily, that works. I've obviously done something wrong. Maybe I'll make an addendum to fix that in the next video. What I will say, though, is that all this code is freely available. You can check it all out. Everything from the Dockerfile to the Helm chart. You can make modifications. You can fork it. You can play around with it. None of this is tied to my accounts, and it's using completely off-the-shelf stuff. Raise an issue, write a comment, let me know. I hope that this has been an interesting video. I just made this sporadically because I thought this stuff is so fascinating, and there's really not a lot of good stuff out there that really describes this. So please do let me know your thoughts. And again, like and subscribe, and comments are always welcome. Thanks again.